Relativity, one of the greatest achievements in physics developed by Albert Einstein, completely changed how we understand the universe. It's not just about space or time. Relativity redefines reality itself. But what does relativity really mean? And what are the core ideas that make it so revolutionary? Welcome to Grossdenken, everyone. In today's video, we'll break down the top 5 concepts that define relativity. These concepts are rooted in proven science, and by the end of this video, you'll see why relativity is one of the most important theories in history. Please support this channel grow by just subscribing. That would mean a great help. Let's dive in. The first concept that defines relativity is that the speed of light is constant. Einstein's theory of relativity starts with this incredible idea. Light always travels at 300,000 kilometers per second, or 186,000 miles per second, in a vacuum, no matter what. This means that whether you're standing still or traveling at half the speed of light, you'll always measure light speed as the same. This constant speed of light creates strange effects, like time dilation and length contraction, which we'll explore soon. But this idea also challenged classical physics, which assumed speeds could just add up. To put it simply, light doesn't obey the same rules as cars or planes. It's a universal constant, and it's the foundation of relativity. The second concept is time dilation, and this is where things start to get really weird. Einstein showed that time isn't absolute, it's relative. Here's what that means. If you're moving close to the speed of light, time passes more slowly for you compared to someone who's stationary. For example, an astronaut traveling near the speed of light might experience just a few days, while years pass for people on Earth. This effect has been proven by experiments with atomic clocks. In 1971, scientists flew atomic clocks on airplanes and compared them to stationary clocks. The clocks on the airplanes ticked more slowly, exactly as predicted by relativity. Time dilation isn't science fiction. It's a real consequence of high-speed motion. It's why GPS satellites, which orbit Earth, must account for this effect to provide accurate location data. Next up is length contraction, another mind-bending consequence of relativity. Here's how it works. When an object moves close to the speed of light, it appears to shrink along the direction of its motion. This isn't just an optical illusion. It's a real physical effect caused by the nature of space-time. For example, if a spaceship were traveling at 90% the speed of light, it would appear much shorter to an outside observer than it would to someone on the spaceship. Length contraction and time dilation go hand in hand. Together, they show that space and time aren't fixed. They warp and change depending on your motion. These effects might sound bizarre, but they've been confirmed by experiments, such as observing fast-moving particles in particle accelerators, which behave exactly as relativity predicts. The fourth concept is perhaps the most famous equation in physics, E=mc squared. This equation shows the equivalence of mass and energy, meaning that mass can be converted into energy, and energy can be converted into mass. Here's what it means. The E stands for energy. M is mass. C is the speed of light, which acts as a conversion factor. Because the speed of light squared is such a huge number, even a small amount of mass can produce an enormous amount of energy. This is the principle behind nuclear reactions, such as those in the sun or nuclear power plants. For example, when hydrogen atoms fuse in the sun, a tiny bit of their mass is converted into energy, which powers the sun and provides the light and heat we experience on Earth. E=mc squared is more than just a famous equation. It's a fundamental insight into how the universe works. The fifth and final concept is the idea of space-time and how it relates to gravity. Before Einstein, gravity was seen as a force between two objects, like the Earth pulling on the Moon. But Einstein's general theory of relativity redefined gravity as the warping of space and time. Imagine space-time as a flexible fabric. Massive objects, like stars and planets, create dents or curves in this fabric. Smaller objects, like moons or satellites, follow these curves, which is what we experience as gravity. For example, the Earth orbits the Sun not because the Sun is pulling on it, but because the Sun's mass creates a curve in space-time that the Earth follows. This concept has been confirmed by observations of gravitational lensing, where light from distant stars bends around massive objects like galaxies, exactly as Einstein predicted. Space-time and gravity aren't just abstract ideas, they're the framework of the universe itself. To recap, the top 5 concepts that define relativity are: the speed of light is constant, time dilation, length contraction. The equivalence of mass and energy, E equals mc squared, space-time and gravity. These ideas might sound strange, but they've been proven by decades of experiments from atomic clocks to gravitational waves. Relativity isn't just a theory, it's the key to understanding the universe. Which of these concepts blew your mind the most? Let me know in the comments. And if you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more videos about the fascinating world of physics. Thanks for watching, and until next time, stay curious.